Now, typically with Hadoop MapReduce, you can simply um, select a step and say that, hey, I have a custom jar that I created that I would like to run on the node. And if you select this, you can simply specify the S3 location of a jar file that you created, the one we just created in Eclipse. Just upload it to S3 and then give the location here. But I'm going to show you how to manually run the jar file from within the Hadoop cluster once it's launched. So we've just configured a Hadoop demo cluster with a few M1 small instances, and we don't have any other additional applications that are going to be installed. So we're just going to create this cluster. Okay, now we have a running Hadoop cluster that's just waiting for us to execute commands on it. Now again, you need to make sure that termination protection is on, and you also configure the cluster to not terminate after all the steps have been completed. So this is a running Hadoop cluster. First thing we can do is we can get the master DNS name. If you want to copy the jar file to this cluster, you will need to use a program like WinSCP, or if you're on a Linux machine, you can simply SCP the actual jar files into the master node of your Hadoop cluster. Just give a username as well as the private key file, and it should let you log into the cluster. It'll ask you to confirm that the host key will be added to the cache, and it may take a few minutes. And then once you're in, you should actually be looking at the main home directory of the Hadoop cluster. Now with WinSCP, you can simply drag the required file into the remote folder that you want to copy to. So our file is wordcount_java.jar. Let's just copy it over. And once the copying is complete, it might take a few minutes, because this jar file might be quite big because it includes the entire Hadoop library. Okay, now that the file is copied, let's go ahead and log into the cluster, and we'll see how we can run this program from command line. Now, once you have a working Hadoop cluster, within the cluster, assuming the environment variables are all set up and the executables are all defined in path, if you just type the Hadoop command, you should be able to perform several operations with your Hadoop cluster, including stuff with HDFS as well as running a Hadoop jar file. Before we run this job, let me just go ahead and create like a simple word count text file. So let's go ahead and say let me create a new file. So let's say input, right, and I'm just going to say the quick brown fox jumps over the lazy dog. And just add another sentence just to make sure that we have at least more than one word appearing at least more than once. So just create a file. Now in your Hadoop cluster, you also have the Hadoop distributed file system. Typically in the older Elastic MapReduce jobs, you may have used S3 as a data source, but in this we're going to put the files into HDFS and use them as the input to the job. So I'm going to say Hadoop fs -ls/ if you just want to see the contents of the Hadoop distributed file system. The command takes a few minutes, but it should show you just a /mnt partition. Sorry, a /mnt folder that's on HDFS. So let's just create a folder. I'll just call this /input. And if you repeat the previous command, it'll show you what is available inside the HDFS. So you can see that folder we just created in HDFS. So let's put this file that we just created. So let's just say the same command, Hadoop FS. We'll just say dash put input.txt in/input. Run this command. Will take a few minutes, and that's done. If you want to verify that the file's actually in HDFS, simply do that, and it should show you the contents of what's inside input.txt. Okay, once everything's ready, let's just go ahead and run this job. It'll take a few minutes to spin up, and it's started running the job. You should be able to see some of the information regarding how the mappers and reducers are executing. The map tasks have completed. It's going into the reduce task now. Okay, the job finished executing, and if you notice, we ran a number of map and reduce tasks. In fact, it ran 8 default map tasks and 3 reduce tasks, and this can be definitely optimized, especially for a small job like this where you virtually need just a single map and a single reduce task. It's written out the output to HDFS, and to check that we can just simply use the command Hadoop FS -ls /output, for example, because that's the directory we specified where the output should go to. And you'll see that for each reducer it's actually written out an individual file. So if you want to sort of cat these files, we can do that using the Hadoop FS command itself. So if we just say Hadoop FS -cat, name of the output file that we want to look at, it'll actually access this file from within HDFS and print out the words. Obviously, if you want a single output from this job, you need to make sure that you've put a single reducer. You need to make sure you have a single reducer running if you want to have a single output. Since there were 3 reducers, the key space was evenly partitioned between them, and the intermediate keys got distributed among 3 reducers, and the 3 reducers actually returned 3 individual output files for the job. And that's it for this MapReduce demo.